This is a question from thermodynamics. Question you see a PV diagram there. Okay, but that PV diagram, yes, it's a PV diagram. Must be careful. Okay, a quasi-static cycle of a monoatomic ideal gas. Quasi-static monoatomic ideal gas contains an isothermal process. AB. It's marked. AB is an isothermal process. AB is isothermal process followed by an isochoric process BC, constant volume, and an adiabatic process Ca, as shown in the figure. The volume of the gases are V1, maybe initial volume is V1, and in the isochoric process the volume is V2 at A and B respectively. If the cycle has heat input Q1, Q in, heat input is taken as Q in and output is taken as Q out, then the efficiency of the cycle is defined as eta equal to Q in minus Q out by Q in. Q in minus Q out actually is the work done. Worked by heat input is the efficiency. It's also log 2 is given as 0.7. Fine. Now the options, if you look at the option, everywhere they have given you a ratio V2 by V1 8 ആണ് എല്ലാത്തിലും തന്നിട്ടുണ്ട്. V2 by V1 8 ആണെന്ന് തന്നിട്ടുണ്ട്. അപ്പം നമുക്ക് ത്രൂ ഔട്ട് V2 by V1 8 എടുത്ത് ചെയ്യാം. ഓപ്ഷൻസ് വായിച്ചാൽ നോക്കൂ, ലാസ്റ്റ് ഓപ്ഷൻ എന്താണ്? V2 by V1 8 ആണെങ്കിൽ പ്രഷർ ഓഫ് ഗ്യാസ് അറ്റ് എ ഈസ് 4 times പ്രഷർ അറ്റ് ബി. അപ്പോൾ ബിയിലെയും എയിലെയും പ്രഷർ കമ്പാരിസൺ ചെയ്തിട്ടുണ്ട്. And the temperature of gas at A is compared with that at C. അപ്പോൾ എയിലെയും സിയിലെയും ടെമ്പറേച്ചർ കമ്പാരിസൺ ചെയ്തിട്ടുണ്ട്. Okay. So what we can do is this, see the volume is V2 by V1 ratio തന്നിട്ടുണ്ട്. Okay. So we know the volume at B and A and this is isothermal process. നമുക്ക് പ്രഷർ കണ്ടുപിടിക്കാം. അതുപോലെ ഇത് അഡിയബാറ്റിക് പ്രോസസ് ആണ്, നമുക്ക് അതിൻ്റെ ടെമ്പറേച്ചർ കണ്ടുപിടിക്കാം. And they are asking you heat released in BC is smaller than. Heat released കണ്ടുപിടിക്കണമെങ്കിൽ we need to know the temperature. അപ്പോൾ ടെമ്പറേച്ചറിൻ്റെ റിലേഷൻ നമുക്ക് ഈ അഡിയബാറ്റിക് പ്രോസസ്സിൽ കണ്ടുപിടിക്കാൻ പറ്റും. Because isothermal അത് കോൺസ്റ്റന്റ് ആണല്ലോ. So let us say the temperature throughout the isothermal processനെ നമുക്ക് T0 എന്ന് വിളിക്കാം. Let us say temperature in the isothermal process AB, അത് T0 എന്ന് വിചാരിക്കുക. Let's say the temperature in the so that means എയിലെ ടെമ്പറേച്ചർ will be T0, ബിയിലെ ടെമ്പറേച്ചർ T0 ആയിരിക്കും. ഓക്കെ, ആൻഡ് ടെമ്പറേച്ചർ ഇൻ സി ഷുഡ് ബി ഡിഫറെൻറ്റ്. അതൊരു T dash ആവാം, T0 T dash ആവാം. The pressure is decreasing, so temperature should change. ഓക്കെ, ഇനി ഓപ്ഷൻ ഏതെങ്കിലും കിട്ടുമോ നോക്കുക. Pressure of gas at A is 4 times pressure at gas B. Okay, let's do one thing. Let's take the adiabatic process. Which is adiabatic process? AC is adiabatic. AC adiabatic. Adiabatic and gamma is important. So let's calculate gamma. What is gamma? It is 1 plus 2 by degree of freedom. Degree of freedom monoatomic 3 ആണ്. So this is 1 plus 2 by 3, which is equal to 5 by 3. But in many equations, you will need gamma minus 1. Gamma minus 1 എന്ന് പറയുമ്പോൾ 2 by f ആയിരിക്കണം. That is 2 divided by 3 ആണ്. Gamma minus 1 വേണം നമുക്ക്. So അതവിടെ ഇരുന്നോട്ടെ. Now we can relate in the in the adiabatic process, we can relate volume and temperature. അതെങ്ങനെ ചെയ്യുന്നത് നോക്കൂ. Volume V1 corresponds to the temperature T0 because that is at state A. The equation, okay, let me write the equation first. The equation is TV raised to gamma minus 1 is a constant. So we'll take a temperature T0 and volume V1 raised to gamma minus 1 should be equal to temperature T dash and the volume is V2. V2 raised to gamma minus 1. V1 T dash. So T dash is nothing but T0 into V1 by V2 raised to gamma minus 1. V1 by V2 is given. V2 by V1 is given as 8. So V1 by V2 will be 1 by 8. So this is T dash is equal to T0 into 1 by 8 to the power 2 by 3. 1 by 8 to the power 2 by 3 is 1 by 8 to the power 2 by 3, and that is equal to cube of 8 to 2 squared is 4. So T0 by 4. So temperature T dash is T0 by 4. This is T0 by 4. So temperature at A is 4 times the temperature at C. Correct? Temperature at A. Temperature at A എത്രയാ? അത് T0 ആണ്. Temperature at C എത്രയാണ്? T0 by 4 ആണ്. So this T0 is 4 times temperature at C is correct. അപ്പം ആ ഒരു ഓപ്ഷൻ അല്ലേ, V2 by V1 8 ആണെങ്കിൽ ടെമ്പറേച്ചർ ഈസ് 4 ടൈംസ് എന്ന് പറയുന്ന ഓപ്ഷൻ സി കറക്റ്റ് ആണ്. ഒന്ന് കിട്ടി, രക്ഷപ്പെട്ടു. ഓക്കെ, ഹാപ്പി അല്ലേ? ഇടയ്ക്ക് ഒരു ആൻസർ കിട്ടുമ്പോൾ ഒരു സന്തോഷമാണ്. Now what about pressure? Pressure കണ്ടുപിടിക്കാൻ നമുക്ക് you can use this thing, what you call same adiabatic relation, because pressure at A and pressure at B. A യും B യും ആണ്. We need to calculate the pressure at A and B. Pressure at A and B. That's an isothermal process. Okay. In isothermal process, temperature being constant, we can write P1 or PV is a constant. PV is constant. So you want pressure at A. Pressure at A, let us call this pressure at A as PA. And then you want pressure at B. Pressure at B, let's call it as PB. P at A, pressure at A, and the volume is what? V1. Equal to P at B, pressure at B, and volume is what? Volume is V2. V1 pressure at A. Pressure at A is nothing but PB into V2 divided by V1. And V2 by V1, as per question, is 8. So PA is 8 PB. So it is not what you call 4 times. It's 8 times. So this option is not correct. Option D is incorrect. Okay. Now for a given, okay, now efficiency. Let's work out question option A. Heat released in the process BC. What is process BC? BC is an isochoric process. BC is isochoric process. So what is the heat released in isochoric process? Heat released in isochoric process. We'll just place this again here. Okay, that BC isochoric. In isochoric, heat released delta Q. Delta Q is equal to N CV delta T. N not mentioned, so let write it as N itself. CV is a monoatomic alle. CV 3 by 2 R into delta T. It said B to C on a process. B to C, BC. So BC final will be T0 by 4 minus initially is T0. So this will give you 3 by 2 NR into minus 3 T0 by 4. So that is basically minus 9 by 8 NR T0. See, what I calculated is heat transferred, and the heat transferred is negative. That means heat is given out. So heat released on. Heat released in BC ആണ് നമ്മൾ കണ്ടുപിടിച്ചത്. So delta Q in BC is actually 9 by 8 NR T0. It is released because it's given us, it's came out as negative. Next one, you have your other process AB. AB As we said earlier, അതൊരു adiabatic ആണ്. AB adiabatic ആണ്. And adiabatic, AB is not adiabatic. AB is isothermal. Okay. AC is adiabatic. AB is isothermal. AB is isothermal. In isothermal process, we know first law says that delta Q equal to delta U plus W, right? And delta U equal to 0. Therefore, delta Q is equal to W, and that is nothing but nRT log V2 divided by V1. nR, what is the temperature throughout the isothermal? That is T0. T0 into log of V2 by V1 is 8, which is nR T0 log 2 cube, which is 3 nR T0 log 2. And log 2 in the question is given as 0.7. So 3 into 0.7 will give you 2.1 nR T0. This is the heat transferred in the process AB. It is 2.1 nR T0. Now compare these two. One is 9 by 8. One is 9 by 8 and one is 2.1. And we know that 9 by 8 is smaller than 2.1. So heat released in the process BC is actually smaller than the heat absorbed in the process AB. Option A is correct. Option A is correct. Okay. Now option B നോക്കൂ എന്താണ്? They are talking about the efficiency. Efficiency. What is efficiency? Efficiency is Q in minus Q out. This is നോക്കൂ adiabatic isothermal processലെ ഇതാണ് Q in. Isothermal അല്ല isocorical ഇതാണ് Q out. So you want Q in. Equation ഇത് എവിടെ ഉണ്ട്? ഈ equation ആണ് Q in. Q in is 2.1 nRT0 minus 9 by 8 വേണമെങ്കിൽ simplify ചെയ്യാം 1.125 വരും. So this is 1.125 nRT0 divided by 2.1 nRT0. And all these term നോക്കൂ ഇതിലെല്ലാത്തിലും nRT0 ഉണ്ട്, that will get cancelled. So that means the efficiency for we have calculated this efficiency for a particular value V2 by V1 equal to 8. So when you are given a particular value V2 by V1, it's like 8, then the nRT0 cancels out. It does not depend on the temperature. That's what they said. It is independent of the temperature. So option B is also correct. 3 options, A, B and C are correct and D is wrong. കുറച്ച് സമയമെടുക്കും ചെയ്യാൻ അല്ലേ? ഇത്രയൊക്കെ ആലോചിച്ചുണ്ടാക്കണ്ടേ? എന്തായാലും that's it.